Hi, this is the Tempter podcast where we discuss embedded Linux, IoT development, and anything else we find interesting. Your hosts today are Kim Raj and Cliff Brake. How are you doing today, Kim?
Hey Cliff, I'm doing fine.
Great. So our topic today is developer workflow and productivity. So we're going to go through some concerns we probably all have as we think about our work and trying to get things done. So, how do you want to start, Kim?
Yeah, it's a very interesting topic, and I think what differentiates a person, is basically their workflows, how they organize their work, and particularly will basically, if you touch any aspects of work, the way your workflows feed directly into your productivity, and so in this case, developer workflows feed into developer productivity. So I think it is very important that this is addressed, and I'm sure that everyone is very interested to know about what their ideal workflows are, and it's always being optimized for that.
Sure. Yeah, that's a good way to put it. So, looking at it as kind of a sequence where one helps the other. So as we work on products and various engineering projects, one of our challenges is always finding the right people. As systems get more complex, there's more specialized knowledge needed. So what are your thoughts around that?
Yeah, so I think putting my open source hat on, I think that the remote work is here to stay now. A lot of times people thought about it is a pandemic thing, but I think pandemic just proved it that it is possible. So I think especially around specialized knowledge and work that you just mentioned, it becomes even very important pillar for getting people to be able to work anywhere, but then you have the right people, um, and don't have restrictions of place, geographic locations, um, and this just is going to be a effective way, as I see moving forward.
Hmm. Yeah, it really is amazing some of the workflows and tools that the OSS uh, projects have pioneered and the things they've come up with. Just a few things like Git. And
Yeah,
while GitHub isn't an open source project, it's very much centered around open source work.
yeah,
And that spawned other tools like GitLab and Gitea. And these tools really help us synchronize, give us synchronization points for keeping work in sync between distributed people. And
hmm,
it works quite well. I really enjoy it. It's quite fun. Um, I like the transparency, and I think a lot of in-house development efforts, even if you're all sitting next to each other, even adopting these workflows really have benefits that go far beyond distributed work. So I think
yeah,
we all have a lot to learn there.
yeah. There is a term called inner source, which is essentially something that within an organization, let's say within back systems, right? You have many people working on different projects. You can not work in open, let's say, then you can have something called inner source, which is basically your teams are working with each other in a transparent manner inside your company firewall, and that in itself improves quite a bit of productivity and reuse and all that good stuff. So
Hmm.
um, so essentially it's not one different way, definitive way of doing work, that you just write your code and then you put it out there in open internet. um, when you say open source development methods, it can be applied anywhere.
Yes, for sure. and we've seen projects that go both ways, and we've really experienced the benefits of this. So it's really a nice workflow. So one comment you made at one point was work will tend to be asynchronous with synchronization points. How do you What are your thoughts around that?
Yeah, so I think if you look at, there's a lot of synchronous work that has happened. If you look into the, you know, the industrial era, and you did a lot of work. You went to an office setting and you did a lot of work there, and you basically optimized your workflows around that. But I think as the knowledge work has become more and more prominent, the need to do so has become a little bit, um, as not as prominent. And the reason being, cognitive work involves a lot of thinking, a uh, lot of asynchronous, thoughts. And at certain point, you iterate over it for a while, and then before you come to a solution or a possible solution, you try a few different things, um, all that in your own capacity. And then at a certain point where you feel like this is now something that is shareable, or rather is something that can be made as plan of record, and those are the synchronization points, which means that you are synchronizing um, at given points, and that is something you can have fixed synchronization points. You can have um, variable synchronization points. You can have the more or less tools which are doing the synchronization for you behind the scene. So there are several different ways that you can implement that.
Mm-hmm.
Um, so you
Yeah,
will.
I think that's a very helpful concept to think about work in terms of asynchronous and synchronous. And it seems to me that synchronous work is expensive work. You think of a long meeting where we're not getting much done. That would be
Mhm.
kind of an extreme example. Um, but yeah, if we can mix the two and have the right balance, that really seems powerful.
Yeah, absolutely. Yeah, I think there are tools now that are available that helps in a lot of these communications. And a lot of this information that was only possible through synchronous meetings or other ways, face to face, etc. There are more tools now available that, a lot of that work that you do can be separated out. And you can just say that, the I would go from asynchronous to synchronous, right? As the cost of asynchronous is way lower than synchronous. You would put, does this require an email exchange, right?
Hmm.
Does this require a write up, right? And does this require me calling someone, or does this require a video call, or does this require me to travel there and talk to people in face to face? So
Yeah, yeah. There's certainly certain tasks and challenges that are best done in different ways. So being able to differentiate that, I think one thing that really helps asynchronous work is transparency. So if you're writing some code and you open up a PR at the start of your work and then you're committing, anybody who's interested can watch that at their own time and interest. And you don't have to schedule meetings. The information's just flowing by, and anybody can you know dip their hand into the stream anytime they want. So it allows people to kind of work at their own pace and interest.
yeah,
But you have to commit to transparency. You have to be willing to be vulnerable, to start a PR as soon as you do the work instead of when you finish it.
yeah,
And that really smooths out the asynchronous work process. And then maybe your synchronization point could be a review and then a merge to main.
Yeah.
Um, More formal methods like Scrum would have a meeting every day or every however many days as a synchronization point.
Yeah.
But I think as teams really get going, sometimes those methodologies, while needed in some cases, maybe overkill in others.
Yeah, I think there are tools that will come in future that will be driven by some sort of AI, and they will be as effective as data is fed into them. So
Hmm.
um, synchronous points don't generate a lot of data. They may generate decisions, but asynchronous will generate a lot of data, and that data is very important for those tools to be effective. So essentially, I think this will give rise to a usefulness of those kind of tools.
Yes. Well, it seems like this could be an entire topic: asynchronous versus synchronous work, or maybe even a book. So
Indeed.
it's an interesting topic. One
Mhm.
last thing I'll say about this is chat is a really interesting tool we have, and there's lots of ways to do it. But it seems to be a really key ingredient for distributed teams to really gel together and develop relationships. And the interesting thing about chat is it can be synchronous or asynchronous. So I might write you a message in a chat thread and you won't see it for 3 hours. And then you'll reply, and I may be at my computer then, and we go back and forth a few times synchronously, but then it turns asynchronous again. So it's just kind of a neat tool that can be either, and I found it really beneficial for distributed teams.
Yes.
So as we think about development, how do we accelerate the rate of development?
Yeah, I think rate of development is everybody is looking after. I mean, you talk to any organization and they'll give different terms to it, but somebody will call feature velocity or other names, right? But essentially, all they're looking for is, how do I accelerate the rate of development?
Mm-hmm.
And if there was a simple answer to it, everybody would have been done with it. But I think there are a few things that would help you in achieving some of it. And rate of development, essentially, you have to really make sure that the rate of development is about effective features, so you're not like running in a hamster wheel, right? Sometimes you do busy work, and that is not part of accelerating your rate of development, right? And sometimes you may misconstrue that. So what I mean by doing that is that, say you have a repetitive task and you find that, oh, I can do it, I can do five of them in parallel. But what would be effective is if you can offload that task to an automation task like a continuous integration or some sort of other tool that will achieve that task. What it does is, as a human being, it removes the cognitive overload that will be on you um, to get that done. You might have written down a script, for example, to do a build, whatever. But the fact that you have to issue that manually is cognitive overload. Because if you miss that, then the build may run for an hour and a half. And you might go on to a different meeting or different task, and that won't happen for an hour and a half. So um, it's important that you automate that kind of tasks which are repetitive, and you delegate them to some tools. There are like CI tools, for example, Jenkins, GitHub Actions, you name it. There are plenty of them out there. Some of them are even integrated nowadays with your infrastructures like GitHub, GitLab, etc. So that's one part I would think, and there are more, I guess. What's your idea on the development, increasing the rate of development?
Yeah, it's an interesting topic, and it's kind of always hard to it's kind of hard to nail down all the time what's happening when it feels like a team is slowing down and struggling to get work done, or when it's going really good. But yeah, I think you're onto something there. CI, CD, and what these automations do is they allow us to release and test more often. And when we release often, that feels good. When we can deliver something more often and have confidence in it, it just makes us feel good. It improves our morale.
Mm-hmm.
It energizes the team. So I think it's, I look at a development effort or a team as kind of a big flywheel. It takes a lot of effort to get it going, and it's just these little pushes, a little automation here, a little automation there, little improvement, and your flywheel starts going faster and faster, and then it just helps everything. But it's kind of a question I ask often: is my flywheel going, is it speeding up, or is it speeding down
Mm.
or slowing down? So that's really the, what direction am I heading? And probably the thing that slows us down the most is technical debt.
Yeah.
And that's just when we haven't taken care of things. There gets to be a lot of busy work. We're not confident in our design or our software. So when we release it, we have to do a lot of checking, and there's a lot of uncertainty, and will this release break? And all that stuff just slows us down. So if we can avoid all that, and avoid technical debt, that technical debt is just a quagmire. It's like a bog. You just feel your feet sinking, and it's
Yeah.
a
Yeah.
struggle just to even walk. So
Absolutely. Yeah, I think technical debt, I can just see this from, if I say, from, some of the open source projects I maintain. And some of them are because the project is downstream of some upstream project. Usually distribution projects are like that. And you may be supporting an esoteric architecture, and you say, "Oh, there's this nice patch I did to ZBox or component B, name it, like libc or whatever,
mm-hmm.
and it made it work, and you are so happy you made the release, and that architecture is, or that particular sock or machine is now working in your distribution. um, but if you forget about that patch, next time you upgrade your libc to a newer version, it may break,
Mm-hmm.
because you might have touched the code in the areas where upstream is doing different changes. Maybe they are reorganizing, maybe they are changing, rewriting, god forbid, right?
Mm-hmm.
So and now suddenly when you go from version 1 to version 2, your patch has to be redone, right? So you did it once, you're doing it again, and you'll keep doing it again and again as long as you maintain it. So there's a huge cost that you attach it to, the technical debt that you're accruing. And it only starts with one, and then you'll have maybe a different branch, different product, and it just spirals. So, for example, in this case, what you would do is when you do that patch, you would basically spend some time as part of your development and looking at upstream and opening up a discussion there through whatever methods the upstream follows. It could be an email, it could be a bug tracking system, it could be a Discord discourse, you name it, right? So whatever the community interaction platforms are in use, it's better to use it right then and there and add a discussion about this, and then point, hey, this is how we fixed it. It may not be ideal because you're not upstream developer, or it may be. And a lot of times it is. So what then you do is you're basically opening that thread up where this will be upstreamed, and you are paying back your debt that you haven't yet accrued.
Mhm.
And so this really works well for a couple of other reasons. One is that the community knows that you are working on that certain area of the problem. So if there is someone else, they join hands with you. If upstream is looking for someone, you are developing that expertise. So they may engage you in that capacity. In general, it is a win-win at that point. There is a cost, a little bit of cost associated with it when you do it, because let's say you develop that fix in a day, it might be an hour or maybe a couple of hours for you to interact, do all these things I talked about. So yes, there is a cost, upfront cost to it, but it's way, way less than, say, you would be spending days later on forward porting that patch, to your product or whatever in future.
Yes, that's an excellent example. And one of the hardest systems to maintain is a Yocto build where there are dozens and dozens of BB appends, and just dozens of components are modified with little patches, and
Yeah,
and any of that can be pushed upstream. Like you said, it takes more time up front, but when we go to upgrade, it's easy,
yeah,
and that's what we want.
absolutely.
So, kind of along these lines, what about efficiency? How do we be more efficient?
Yeah, so I think, whatever we talked so far, efficiency lies underneath it, isn't it?
Mm-hmm.
How do you become efficient, right? So as we know, we talk about it, and you look at a number of lines of code for, big projects like the browser, the kernel, it's always going up and up and up. What that tells you is that the system is getting complex. As it gets more features, more support for more different machines or um, different kind of use cases. So there is a constant battle that you will have to fight, which is that you focus on simplicity. What that means is um, you keep working on the solution even when it is done. So this goes to also is saying, find a bug somewhere. So it says that, leave the code better than you found it.
Mm-hmm.
Right. So I'll cite that as an example here, because what you're doing is you look at that particular piece from maybe a different vantage point, and you see, okay, there is this redundant code or dead code that basically can be thrown away if I do this. But that's not part of the thing that you're supposed to do right now. But I would say that because you prioritize focusing on simplicity, you may say, yes, this is part of that job. So this is a process, it's a gradual process. It is not something, okay, today I will be focusing on simplicity. It doesn't work that way, right? It has to be a ingredient of your development workflow. So there are these kind of examples that'll make you more efficient, because it's like, when you go for a walk and then you find a little pebble on the road, right? And you just pick it up and put it aside, because then next time, or the next person who is walking through that doesn't hit that, right? So it's very similar approach.
Yeah, so basically, efficiency requires investment,
Hmm.
and that investment then will provide a return in the future. So yeah, I like that. Yeah, and this it goes at the applies at the group level, personal level. I mean, we can always invest in our own skills, or the tools we have, how well we can use them, and in the end, sometimes we have to regroup. If we build something and we get mired in complexity, we occasionally have to step back and look at the architecture, look at our data structures, look at how we're communicating. And kind of my test for architecture, if it's getting simpler, it's probably heading in the right direction. If we're continually adding layers and layers on top of an architecture, and each layer tries to fix the problems in the previous layer, then we're probably not heading in the right direction. So
Yeah, that's a good measure. It's like the thermometer, and layering adds basically complexity, which is opposite of simplicity.
mm-hmm.
And in some cases, it may be justified, but in many cases, it is not. And a right amount of layering is fine. But I guess if you're layering for the purpose of, hiding the interfaces from the bottom layer for whatever reason, maybe it is better to look at the bottom layer and say, hey, do we really need this here, or can we get this accomplished in the bottom layer itself? And so asking those kind of questions at the right time in the right place in your software stack, for example, goes a long way uh,
Yes, for
in the.
sure. Yeah. So one question a lot of developers are probably asking is, how will AI impact me? How will it change my job? Will it put me out of work? Will it help me? So I'm sure you've done lots of thinking on this. Do you have any thoughts on where this is all heading?
Yeah, I think everybody has their take on it, but generally, what I would think is, it is here to support you, to help you, and it just will make you more efficient, in doing things that you haven't been able to do so far. And to give you just my own example, I would be writing code in my editor, and then I'll have like a language server, that would basically give me hints when I'm typing a function, or it'll tell me about, hey, this is the prototype for this function, right? um, if there is a AI um, assistant, which would basically give me the whole shebang about it, like saying, hey, these are the side effects, these are the ways it is used in C and C++, and yada yada, and you need to use FFI. Why not? And
Mm-hmm.
I will just be happy to have something of that nature. And so what I would see is, we've seen this, in the productivity landscape in the past, right? We all started in assembly many decades ago.
Yeah,
And
people
then,
who are as old as us anyway.
yeah, and then when the C compilers came, people said, oh, now the programmers are obsolete, right?
Mm-hmm.
Because programmers were equal to assembly programmers, right? But look, C gave rise to C programmers, which is probably way more number of programmers than, say, the assembly programmers were. And then, you just can keep thinking about it in the same line, and you see that, the amount of developers we have today, right, um, is because of, the compiler, for example, that came underneath and took away a lot of the details that were basically mundane or were boilerplate at that point, those kind of stuff. Um, so I think I'm just seeing that it is going to be in the same realm, where it'll basically make you more productive. And the definition of programming, as I said, is your programming systems, and language is a tool. I've been always saying that. whichever language you use. It's like your chainsaw or hacksaw or whatever. So this is just basically another tool in your kitty.
Yeah, that's a good way to look at it. And we've seen many changes in automation,
Hmm.
and over the last couple centuries, and sure, it does displace some people for some amount of time, but in the end, it seems like there's more opportunity.
Hmm.
And really, if we can do more with less effort, society should be richer.
Yeah.
And when there's more wealth in society, there's more opportunity.
Yeah.
So I think I see it as more of an incremental change. I know a lot of people are picturing AI as like this huge step change that's just going to drastically turn
Mhm.
everything on its head. But in the end, it's just a tool. It makes us more efficient. It requires some investment to learn, and that's just the work we need to put in to learn new tools.
Yeah, I would think that is the right attitude towards it, and use it in your to your advantage. And I think yeah, it'll just make you more productive in many fashions. So we do think about a particular kind of work scenarios, and there are a lot of things you do when you do a job, and there are many aspects of it, process, other things where this will just make you more effective. Yeah, so how do we adapt to this change then?
Yeah, well, there's several ideas that come to mind. Um, one is to avoid lock in. If you get locked into a certain tool set or type of technology, it can limit what you can do in the future. So one thing I try to do when possible is to use open tools when possible,
Hmm.
and generally in the software world, and this is also coming to hardware as well. The open source is usually leading the technology. So
Yeah. I,
using open tools when we can helps.
yeah, I think that's a very good strategy. I would think that if you avoid lock-ins, so most of the times lock-ins are bad, because what that does is, if you are kind of going to innovate on more, either you need to open a new stream or use a different set of tools or something of that nature, or you have a dependency that now you certainly are tied to
Hmm.
uh, quite heavily. So using of using open tools doesn't really reduce your cost, or acquisition cost of those that you would get from a logged in tool, but it gives you flexibility where you can influence using this tool in a certain way for your own advantage.
Yes,
And
right.
that you may make those changes to the tool, you may participate in the community and influence the changes. That in turn helps you, and it's paying your technical debt for maintaining your tools all along. We talked about technical debt. So it is certainly a very sound strategy, I would think.
Yes. Yeah, and I think just the agility, flexibility, maintaining your code, your designs, continually improving them, and we've talked about these topics multiple times from different perspectives.
Hmm.
But one last thing I'll mention is it's important to own the integration points. And what I mean by that is, where different parts of your system come together, if you own those integration points, then you can swap in new components, technologies. But if you don't own the integration point and someone else is in control of that, then it becomes very hard to
Hmm.
change anything or adapt to new technologies. And I think this principle applies to both hardware and software. So I generally encourage people to, you want to own where things are coming together, and then you have the flexibility.
Yes. And in a way, I think that's basically roughly, loosely a definition of a platform that I think we
Mm-hmm.
talked about several times is, it's around the edges, right? And as a platform, you soften the edges, you fine fine grain them, remove some roughness, and you have a very shiny platform.
Yes.
So certainly, what goes underneath is you have a well-maintained code that's supporting it. Your designs are sound, which is basically supporting, your interaction points at the integration points that we talked about, and then you continuously improve them because, more or less these points would become obsolete or new points will come in at an integration stage. So unless you continually improve it, you'll get into that darkness of technical debt and you'll become less nimble.
Yes. Yeah. So that's a lot of good thoughts. Appreciate it, Kim. So if
Yeah.
if um, if our listeners if you have any comments or feedback, we'd love to hear from you. So reach out to us in any place we we're available. Please
Mhm.
share this with a friend if you think they'd enjoy it. And until next time, thank you.
Indeed. Thank you.